All right, hello and welcome back. So this is an ALEKS topic that's called calculating solubility. I'm going to go over two different instances of this topic, and really this first part of this question of this answer box. This is really the key aspect here to understand. I think what we're looking for here is to really understand the concept of what's required to know that you are actually able to calculate the solubility of something. So the actual calculations that we're going to do, when we're able to do a calculation are very straightforward. But I think what's more important is sort of the conceptual understanding of what we're talking about when we say calculating solubility. What does solubility really represent? And what are we, what's required in order for us to know for sure that we are calculating the true solubility of something. And the key thing that we need to sort of, the take-home message is that we need to create or have a saturated solution. That's what we're really looking for. This is the key. If we do not have a saturated solution, then we cannot calculate the solubility. We don't know for sure that is the actual solubility. And the key aspect of a saturated solution is that not all of the precipitate is dissolved. That's the key thing. That's what we need to sort of pay attention to. So like I said, I'll do two examples here and talk through, each example. And this is just the thing to keep in mind. What do we have a saturated solution or not? Okay. So this says a chemistry student adds a quantity of an unknown solid compound X to 1 liter of distilled water at 19 degrees Celsius. So here's our picture over here. We've got 1 liter of water. We've got our solid X. Some of it's going to dissolve, right? So as the solid dissolves, we're going to have little, X dissolved in our solution. And this is after 10 minutes of stirring, which is a good amount of time. If this was like after 30 seconds of stirring, we probably have not dissolved everything yet. But after 10 minutes of rapid agitation, you've probably dissolved all that you are going to be able to dissolve. Only a little X has dissolved. So a little bit has dissolved, but not all of it. The student then drains off the solution. So essentially what we're doing, you can think of we're filtering it or we're just decanting really carefully, where all of the liquid is taken away, right? We're going to take all of the liquid over here. So we've got, again, this 1.00 liters. And not all of this solid is left behind, right? All the undissolved solid is left behind. So the question becomes, is this a saturated solution, right? So I've got a little bit of this X dissolved. Is this a saturated solution? And in this case, the answer is yes, because we have dissolved as much as we can. And there was, we know that more can't dissolve because some of this X was left behind. So it's a saturated solution. And then if I evaporate the liquid from this and I'm left behind with a little bit of solid, then that will allow me to actually calculate what's the solubility. If we stir the solution as much as we can, how much solid is going to be dissolved in the actual solution. We've created a saturated solution. We've taken that and separated it out. So whatever is dissolved, whatever is remaining here, that's going to be, the solubility essentially for this solution. So, let's see. Student then drains off the solution and evaporates the water under vacuum. A precipitate is left behind. So then we're going to take this. We're going to get rid of all of the liquid. And we've just got this small amount of precip of X, which equals 90.0 grams. And all of that 90.0 grams was previously dissolved in the saturated solution. So in order to calculate the solubility equals grams per volume. In this case, we'll just do grams per liter because it's 1 liter. So that's going to equal 90.0 grams divided by 1.00 liters, fairly straightforward. And that's going to be 90.0 grams per liter. So that's our solubility for this compound. And again, the important thing is that we had a saturated solution, right? We always got to go back to, was the solution that we're testing a saturated solution? If yes, then we can calculate the solubility. So yes, we can calculate it, and it's 90.0 grams per liter. Okay, so let's look at one more example and talk through it. So in this one, it says a geochemist in the field takes a small sample of the of the crystals of mineral compound X from a rock pool lined with more crystals of X. He notes the temperature of the pool, 23 degrees Celsius, and caps the sample carefully. So he's basically just collecting a sample of crystals back in the lab, so he's got a solid. The geochemist dissolves the crystals in 1 liter of water. He then filters the solution and evaporates all the water under vacuum. Now, here, this does not say that there was any solid remaining. This does not say that the solution was saturated, right? So if we draw a little picture here, we're going to put in this crystal of X, then we're going to stir it, and according to what we're reading up here, all of it dissolves. The fact that all of it dissolves means that this is not necessarily a saturated solution. It could be, but we don't know for sure that we have created a saturated solution. We don't know that this solution is saturated. So in this case, no, we cannot calculate the solubility because we don't know for sure that it's a saturated solution or not. So that's the key thing that you're looking for. Did you create a saturated solution? Are you testing a saturated solution or are you not? In this case, because all of it dissolves, it's not a saturated solution. We don't know. So hopefully that makes sense. If not, definitely please leave a comment in the comment section below. And thanks so much.